Hello everybody and welcome to our very first PowerPoint in the weather series. Our first PowerPoint is going to be about the water cycle, and basically we're going to be exploring the concepts of where does water come from, where does it go, and what does it do when it gets there, because water. Sir Isaac Newton once said, as he tossed an apple into the air, that what goes up must come down. Now the same could be said for the water cycle, and we could also add that what comes down must go up. You see, the water cycle, it has no beginning, it has no end. Water has been moving up, down, and all around our planet since basically we have had a planet and had water on it. So where did we get all of this water, you might ask? Well, the water on our planet has been here for a very long time, and there are several theories as to where it came from. Some say that it came from the volcanic activity back when our planet first formed. At this point, our planet is covered in lakes of lava and full of volcanoes, and these volcanoes spend the vast majority of every day, all day, going and erupting. And when volcanoes erupt, they release many different types of gases, two of which are hydrogen and oxygen. When the oxygen released from the volcano combined with the hydrogen in the air, it made water. And when the two molecules of hydrogen bonded with the one molecule of oxygen, it formed a single molecule of water, and that is why water is sometimes referred to as H2O. The more you know. The other theory is that water came from outer space. Now, some think that a comet, or probably several comets, crashed into our planet when it was very young and first forming. Now, the ice from the comets melted, and in time formed the oceans and the lakes and the rivers. This just in. As of June 14th, it was announced that scientists have discovered evidence of a vast reservoir of water hiding up to 400 miles beneath the surface of our planet. The water is trapped in a blue mineral called ringwoodite that sits in between the mantle, a hot rocky layer between the Earth's crust, and the outer core. That means that water is not in the familiar liquid, vapor, or ice form, but in a fourth mineral form. This is pretty neat stuff. This was announced in 2014, so stay tuned to your local science channels as they discover more about this. So how much water do we have? Well, quite a bit, actually. We have an estimated 332,500,000 cubic square miles of water on our planet. If I were to build a box, making it 1 mile tall and 1 mile wide and 1 mile long, and I filled it with water, that would be 1 cubic square mile of water. Now, build 332,499,999 more boxes, and you will pretty much have all of the world's water supply crated up into one really big box. But here's the good news, or rather the bad news, you can't drink it all. You ever wonder what it would look like if we took all of that water and we put it all into one place? It would look like this. That tiny water bubble has a diameter of about 860 miles, meaning from the ground to the top is 860 miles as well. And all of that diameter translates into that cubic 332 million cubic square miles that we were talking about a little while ago. Now, of that 332,500,000 million cubic square miles of water, only 2.5% of that is drinkable. There's an estimated 8,400,000 cubic square miles of fresh drinking water on our planet. And an estimated 75% of the fresh water on our planet is frozen at the North Pole and the South Pole in the form of glaciers. That is to say that 6,300,000 cubic square miles of fresh water is frozen at the poles. So that leaves us about 2,100,000 cubic square miles of water, fresh, potable, drinking water for all living things on this planet to drink. Kind of scary, huh? Now, if we were to take that fresh water bubble and put it onto my rather dried out planet here, it would look something like that. Very small. Very tiny. So moving on, what is the water cycle? Well, at its core, the water cycle has 4 basic steps. We have evaporation, condensation, precipitation, and runoff. Our first step is evaporation. And this occurs when the sun shines on the rivers and the lakes and the oceans, causing the water to evaporate and turn into a vapor. Evaporation, underlined word, means when water is turned into water vapor, or when a liquid is turned into a gas. And then we have condensation. Condensation is when the water vapor begins to rise up through the atmosphere and it gets higher and higher in the air. The air begins to cool and the water vapor begins to condense. And when a gas condenses, it turns from its gaseous form to a liquid form. In this case, from water vapor into itty-bitty little tiny droplets of water. These droplets then form clouds in the sky. And the air gets colder, the droplet gets bigger, until the wind can no longer hold them up in the air. And they begin to fall to the ground. And from condensation, we move on to precipitation. And basically, that is when the water falls to the ground. This is called precipitation. We commonly think only of rain as precipitation, but actually snow, sleet, hail, and yes, even fog is considered to be forms of precipitation. After it precipitates, it begins to pool, puddle, saturate the ground, and run off. When the rain hits the ground begins to absorb the water, and this is known as saturation. Kind of like one giant sponge sticking in the sink. You get it full of water, it can't hold anymore, so the water starts running out the bottom. It's the same thing on the ground, only the ground doesn't run out the bottom, it just goes deeper down into the ground, or it begins to puddle on the surface. Can you see it? Can you see the surface of my sponge? It's invisible. It begins to puddle up on the surface of the sponge. Or in this case, as my young friend here is beginning to demonstrate for us, it's puddle time! Time to get on your galoshes and go a-splashing. Once the ground is totally saturated and it can't hold any more water, it begins to pool into puddles, and those puddles begin to run off down into our gutters, into our streams, into our creeks, into our ponds, into our lakes, and into our rivers, and eventually will end up into our oceans. The water begins to run off into rivers and streams. Rivers and streams flow into larger bodies of water, such as lakes and oceans. Yes, I did just say that. I get ahead of myself, you know. What's it guided to? Once precipitation stops at the clouds and the clouds clear, the sun comes out and begins to evaporate the water on the ground. And so, our water cycle renews. It has no beginning, it has no end. In fact, people often get slightly confused that all the water in the world evaporates at one time, and then all the water in the world condenses into a cloud, and then all the water precipitates, and then all the water runs off and around it goes. But in fact, all of these stages are happening all the time, all at once, all over the planet, forever. And I'm getting photobombed by my kitten. Say hello to everybody, Bill. This is Bill the cat. And that's all there is, folks. Bill the Weather Cat says goodbye, and we'll see you next time. Have a good day.